Today, we're dealing with confined spaces and confined space safety. So the first thing is, what is a confined space? A confined space is a space that's large enough for a person to enter and to perform the work, but it has limited or restricted means of exit or entry, what we call limited egress. Now, you might know egress as being those pretty white birds. No, that's egrets. Okay, bad joke. But yeah, entry or exit, the combination of the two is egress. But anyways, a confined space is also not designed for continuous occupancy. You see that in the first set of 3 lines here. These spaces can pose a significant hazard to workers due to their limited access and potential for hazardous conditions. Some of these hazards are entry and exit hazards, just the hazard of getting in and out of that tight space. There can be atmospheric instability, that can mean explosive gases and such. There can be toxic gases in there. It can poison you or otherwise contaminate. There can be electrical shock hazards sometimes. There can be engulfment hazards. Engulfment means being buried alive by either a solid or a liquid. So you could be underneath a pile of grain in a grain elevator. When that dumps on you, you're buried in that stuff. But it also really includes excavations, well, particularly trenches. And then there can be other adjacent hazards, such as moving machinery parts and that sort of thing in the space that might also require you to perform a lockout tagout to protect workers from those hazards. Here we are covering the safety requirements for working in confined spaces. So that's our mission. So here you got a couple of people working on a rescue of somebody in a confined space, and that's an important part of this too. So the safety requirements of confined spaces, or for working in confined spaces. Well, here's that definition again. It is, number one, it is large enough and configured in a way that it allows workers to enter and perform their assigned work. And number two, it has limited or restricted means of entry and exit, limited egress. And number three, it is not designed for continuous occupancy. So examples of working in confined spaces, some of these spaces could be manholes or the spaces around them. You could have boilers, which somebody has to go work inside of. It could be trenches, tunnels, sewers, underground utility vaults. Well, that's really what I was talking about with the manholes, I guess. Pipelines, pits, air ducts, and process vessels. Now notice that trenches is in here. We're about to talk about excavations and trenching. Well, trenches particularly, but other excavations too, can be considered a type of confined space. So we'll be discussing that in more detail next. But anyways, there are 2 basic types of confined spaces. There's a non-permit confined space. That's a workspace free of any atmospheric, physical, or electrical, or even mechanical hazards that could possibly cause death or injury. So the non-permit required confined spaces are spaces that are essentially hazard-free. Sometimes that's open to discussion or different opinions. So particularly in the petrochemical industry, a lot of spaces are considered confined spaces that might not be outside of the plants. And the second one is permit required confined spaces. And yes, there's that abbreviation there for these two, but a permit required confined space, it's a confined space that has real or possible hazards. So that's the difference. There's real or possible hazards. And who gets to define whether it's a possible hazard or recognize it? Well, that depends. And so we'll get to that. These hazards can be atmospheric hazards. There could be physical hazards. There could be electrical hazards in that confined space, or mechanical hazards. So therefore, in permit required confined spaces, the space poses real or potential hazards. So as I started to mention a moment ago, in the refineries and chemical plants and other sites that fall under OSHA's process safety management rules or PSM rules, pretty much all spaces are defined, or all spaces are defined as confined spaces. And because of this, the process safety management rules, it get tight enough that this generally happens, so that you end up with lots of spaces that are considered confined spaces and require permits. Process safety management rules, I'll have to discuss that in another time, but basically the PSM rules are what require the plants, they're OSHA's rules, that require the plants to have a permitting process for various kinds of work. And so if you've ever spent any time or heard of the process in a plant, they have work permits. There's various kinds of work permits that are granted or not granted in the plants for different kinds of work, and that's done by the host company, Exxon or Dow. And so these process safety management rules are what require them to do this, that you're not required to do in a residential job or a commercial job. So that's where the separation of that comes from. There's nothing keeping you from having a permitting process on other job sites. It just doesn't typically happen. So part of these classifications, this picture might be a good one to look at. You're supposed to have a confined space attendant outside that's managing things from outside, paying attention to what's going on down inside the confined space, down or over, wherever the location is. And then you've got the entrants that are working inside the space. And so you have to address the hazards and protect. This one, in this particular picture, there's no respirator being worn that's in there welding, because they've addressed the hazard of the gases, apparently, going to the picture, with ventilation, pushing some air into the space that is then pushing the bad air out. And if you're doing that effectively enough, then maybe that'll work. But that's what we have to address, is the air quality issues is maybe one of the most important things. So what's involved with an entry permit? Well, here are the general things that are required. Generically, there could be other things at a particular plant you're working in. OSHA does not micromanage the confined space entry permit process, but these are things that pretty much have to be on any entry permit. The first one, the description of the space and the type of work that's going to be done. And the next point, the date of the permit and how long it lasts. It usually lasts hours, not days. The test results. For all atmospheric tests, they need to know the oxygen, they need to know the flammable gases, they need to know the toxic gases or contaminants or materials of any kind that are in those spaces. And that's the preliminary test that would be on that permit. Then you might be doing ongoing testing while people are working in there, and that would not necessarily be on the permit. But meanwhile, you need the name and the signature of the person who did that initial testing. And then you'll have the list of the workers who are authorized to enter that space. So the people that are actually going to go in that space, their names have to be on the permit when you created the permit to begin with. Over on the second column, you have to have the means by which the workers will communicate with each other within the space and with the confined space attendant. You have to have any special equipment or procedures that are going to be used in that confined space have to be listed. If you're going to be doing welding, they have to be the welding equipment, and the welding has to be mentioned on that permit. Any other permits that might be needed. If you're going to be doing welding in a plant, that usually means having a hot work permit for all the spark-inducing heat that could ignite any flammable gases that may be around. And so that could be one of the permits. There could be other permits required. The lockout tagout process, maybe. There could be something else. And then finally, you have to have the contact information on the permit for the emergency response team. The idea is to have everything thought through that you might need for any possible scenario of hazard that comes along. And then, and of course, this thing all has to have been signed by your supervisor who is managing that process, the confined space supervisor. So if that supervisor is heading off to a meeting somewhere, they shouldn't be the one to sign this thing, because they had to be on site ready to respond when things go wrong, when the confined space attendant hollers out, sounds the horn, whatever. And so So that's the basics. Okay, here's a sample confined space permit, 2-page front and back of it. They can be much more involved than this. This is fairly simplistic, but it's giving you a place to put the initial results from your tests before you ever got the permit signed and approved. OSHA's PSM rules require that the host company have a permitting system if it manages a specified amount of certain hazardous materials. So those are listed right within the OSHA standards. What quantity makes your company have to follow PSM rules? Okay. Entry into a confined space officially begins when any part of your body passes through the opening, the plane of the opening. So sometimes people have been known to make a joke about that, knowing that rule. They stick their big toe in there. Oh, I'm in the confined space. Ha ha ha. Yeah. And maybe that's not all that dangerous. It probably isn't most of the time. But if your name isn't on that permit, people have been known to be fired even a week or so later, because we have to treat confined spaces very, very seriously. They're not part of the top fatalities in construction. But the only reason is because we don't spend as much time in confined spaces as we do in other kinds of work. And so that's the only reason they're not in the top 4. You know that 2 out of the 3 people who die in confined spaces, we're trying to do rescues. We're trying to perform a rescue of somebody else. They can be traps. They can trap people into going and doing risky things sometimes. So violating those rules can get you fired. The permit itself must be posted near the entrance of the confined space. When I say the entrance, it's more important that it's the exit too, of course. And they must be available. The permit must be available for workers to review. So you want to make sure before you go in the confined space that you have read through the permit and you notice that your name is on the permit, that you're allowed to be in there, that you're on the list. This picture here on the left is showing you the confined space, kind of a confined space stand where the permit could be slipped into a pocket and along with the sign. That's a good idea. It could be something else more like what you see on this board, where you got a sleeve to slip it into. But you've got to have a system where that permit isn't sitting in the back of the pickup truck or in the back of somebody's pocket, that it's posted. Because the idea is if there's an emergency and the rescue team comes, they have to be able to easily, no matter what the panicky situation is going on, that permit has to be handy and available for them to view. So they can see what the hazards are, see who might be in the space, in the pit, in the confined space, whatever it is. And also the confined space attendant has to be there to respond to and fill in the details with the rescue team. Okay, so hazards associated with working in a confined space, of course, they are dangerous. So there's atmospheric hazards you see in the graphic and down below, and there's physical hazards. So the atmospheric hazards could be poor ventilation. The physical hazards could be quite a few things. It could be just something that's restricting your ability to get out of that confined space in some physical way. And then related to that physical hazard could be the engulfment risks of being buried by a liquid coming into the space or a solid. So we use atmospheric meters, mostly 4 gas meters. Many of them traditionally have been 4. So atmospheric hazards such as oxygen depletion, or could even be oxygen enrichment. But so let's see, when oxygen in a confined space is reduced, it becomes harder to breathe. But too much oxygen in a space, as I was saying, that's oxygen enrichment, can make things like your clothing way more flammable than they normally would be. So that can burn you alive, really, because all of a sudden you got a flash fire on yourself. Oxygen isn't flammable itself, but it makes everything way more flammable. And so you want to keep the mixture of oxygen in your space, in the air, between 19.5% by volume and 23.5% by volume. 20.85% oxygen. which is basically 20.9 as you see on the screen. And so we don't need to be that precise. Okay, so beyond that, atmospheric hazards, the toxins associated with each product used in a confined space will be found on the safety data sheets. There's other sources like the industrial hygienists have a manual, and there is the NIOSH handbook. These are all handbooks that can be used, but the ultimate guide is the safety data sheet. And so you have to look up the safety data sheet in your safety data sheet catalog or manual that is supposed to be posted at a handy place on your job site where any employee can view it. Some toxics, such as carbon monoxide, cannot be easily detected by sight or smell. You have to use a meter. They're poison. They may be toxic, but they are not something that you can necessarily smell. So carbon monoxide and carbon dioxide are both examples of that, except that carbon monoxide is 10 times more deadly per percentage than carbon dioxide. So we normally test the atmospheric done in this order first. You see that in the last bullet and a half here. It says oxygen first, because otherwise what you're reading is not that meaningful on the meter because it's not an accurate reading. So if the oxygen isn't correct, then the flammable gases and the toxins those numbers won't necessarily be accurate. Okay, let's see. The physical hazards. Well, electric shock would be a physical hazard. That can occur when power tools and line cords are used in an area of wet floors. There could also be some adjacent hazards of electrical shock that might have to be locked and tagged out. Purging. That happens when a toxic, corrosive, or natural gases enter and mix with the air in a confined space. That can happen from somewhere else within the space. You could have a sludge in the bottom of a big tank that you're in that is emitting the gases that are evaporating out, toxic or flammable. And so that can be a problem. It can also be leaking in from somewhere else. Materials or equipment could fall into a confined space and strike workers. That particularly happens in excavations, but it can happen in other spaces too. And then I mentioned engulfment before. It occurs when a worker is buried alive by a liquid or a solid material that enters that space. Confined spaces that are too hot or too cold, that can be a physical hazard. Another temperature-related hazard in a confined space can be steam. And then noise is a hazard. It's just a little different kind, but that's an energy of sorts that can be very loud, so you might need hearing protection. And in a confined space, it can be amplified because it's bouncing off the hard walls sometimes. And then, of course, another physical hazard is that workers can just get struck or trapped by moving parts, such as augers or belts. That's the machinery that you might have to lock it down, and so that it cannot afford that hazard. So here's a picture of somebody in a confined space with a respirator on the left side, testing the air quality. A lot of times in confined spaces nowadays, we'll wear meters on us. We'll literally have a portable meter on your body, and the sensor might be stuck out right in front of you, what we call the air column, where you breathe from, because that's where you need the sensor at. And then you could have ongoing testing from the person on the outside of the confined space. The confined space attendant could be doing ongoing air sampling. But one of the problems with some of these gases many of them they have a buoyancy level to them. And so you can have gases that are heavier than air collecting near the bottom. And so if you're down at your knees, you're going to be breathing different gases than you would if you're standing upright. And then maybe up at the top of the tank, you could have another gas. So you can have different gases floating at different levels. And so you can't just test the air at the spot you're at. You've got to test at different elevations on an ongoing basis. And so the attendant often will be testing at different elevations on an ongoing basis with a long extension wand for the sniffer. Everyone involved in a confined space must have special training. So the entrant's got to have training in doing the prescribed work in the space, and they've got to have had probably a medical evaluation to wear a respirator if that's what you're wearing, because not everybody can wear one. It requires a certain physical stamina to force the air in through the respirator and suck the air back, in and out, whatever. Yeah, so you get the idea. Attendants, they have training also. And of course, they're at the opening of the confined space. They're there to protect the entrance, but they're also watching for any hazards on the outside that could affect the entrance that they're never going to be able to be aware of. The entry supervisor, they oversee the whole confined space process. Yes, often from a distance. They've got to be there at the beginning, at the end, and be ready to jump in if there's an emergency, because they often will be involved with contacting the emergency rescue team. Also, and then of course the rescue workers, they have to be on call and ready and prepared, and they have to, of course, have regular training. So the entrance, you got to make sure if you're going to be an entrant that you have a valid entry permit, that you know the atmospheric and the fire and the toxic contamination hazards, that you use the specified personal protective equipment listed on the confined space permit, including face and eye protection, gloves, aprons, coveralls, maybe respirators. You got to stay in contact with the attendant to make sure that they are being monitored and can be told to evacuate if needed. You want to be able to be in a position to alert the attendant when warning signs or symptoms of exposure exist. We normally carry on an ongoing conversation between the entrance and the attendant so that the attendant can evaluate the sanity, the status of the entrance. And so if they start speaking gibberish that makes absolutely no sense, you know they're going down and it's time to call for help. Anyways, the entrant must exit the space immediately upon hearing an evacuation alarm from the attendant, or if an uncontrolled hazard is detected. So yeah, the trouble is that oftentimes when oxygen is the trouble, or the lack thereof, you don't have the good sense to get out of the space, and so that's always a problem. So here's a picture of an entrant in here, not wearing any kind of a respirator, but possibly maybe there's no need for it at this point and they're investigating. Sometimes inspectors will go in here, but they've got to have already tested the air quality thoroughly before they're going to come in here without a respirator. They've got a ventilation tube here, so that's obviously what they're using instead. Here's another confined space and not wearing a respirator. Nobody wants to wear these respirators unless they have to, but you can see the big old ventilating hoses back in here. Some of these confined spaces, you can end up in there a long ways back inside. And so there can be hazards that can make it very difficult to perform a rescue of somebody in what we call a horizontal space, where you enter in horizontally into the space. Here's an attendant in this picture, in this cartoonish picture of somebody doing an air sample. They're testing with a wand. So the duties of the confined space attendant, I've kind of mentioned some of those, but you set up a station at the entry exit of the confined space. You keep count of who's in the space. You have to know what work is allowed or disallowed so that you monitor that as much as possible. If it's not listed on the permit, you can't do that work. You might have to get the permit redone. You got to know how to monitor for safety. You got to test the atmosphere remotely using a probe and recognize the safe and unsafe levels. So sometimes you can peek in there, but again, if you were breathing a toxic gas that's emanating out there, that wouldn't be good either. So it just depends. There's a rule that in a vertical confined space, that you anything deeper than 5 feet deep, where you're entering in vertically down into a confined space, not like this picture, then you must set up a tripod or a hoist and actually have attached anybody who's in there to a lifeline where you can do a non-entry rescue and hoist them out. When we're talking about entry like this picture is concerned, you really can't do a non-entry rescue usually, not easily. Maybe if it's all nicely rounded like this opening is, maybe you can, but people tend to get hung up where they cannot be rescued in that fashion. An attendant cannot do an entry rescue. You cannot go in there to rescue somebody as an attendant. All you can do is call for a rescue team to come in. You have to be there to explain what's going on to others that are going to come and do the rescue. As I've got listed in the bottom, I've already mentioned it, but 2 out of the 3 people who die in confined spaces are attempting to do a rescue. So think about that. That means that the original person fell down. Then 2 more people went down. They went going in there to try to rescue their buddies. And finally, it took the 4th person to finally realize that, hey, I better call for help. So, that's how deadly these are, because you know these people, you work with them. And so when you see them down there, you want to jump in there and rescue them. And so that's why I say it's a trap. It's a real serious trap. So here we've got a couple of people getting ready maybe to go in there. We maybe have somebody doing a non-entry testing with a meter. That's probably the attendant. The other 2 are dressed up, ready to go in there. You see the label up here? At entries, you've got to have a confined space entry warning at the entrance of the confined space. It has to be labeled. So here they've got a horizontal tripod. So apparently in this particular case, they're going to be able to do a non-entry rescue. But most of the time, where it's required that you set up to do non-entry rescues is for vertical spaces. This is a horizontal space that they're going into, but what I have up at the top is really about vertical spaces. By vertical, I mean the entry into the space is from up top, like going into the manhole of a street or on the top of a tank or something of that nature. So here's an example of a vertical entry. So they're conducting an ongoing air quality test in this case here, but they've got meters on themselves too. You see that clipped to them, and that's testing their own air quality of what they're breathing. So there's an ongoing test. So the entry supervisor will authorize and oversee the entry. They're going to be the ones signing that permit. They will be well trained in entry procedures. They will know the hazards. They must ensure the entry permits are accurate and complete. They ensure that the proper lockout tagout procedures are being performed. Ensure all equipment required for the entry is available and that everyone understands how it works so that everybody knows what's going on. So you have to manage this thing. They also ensure workers understand the job and know the rescue plan. They've got to make sure that you know the rescue workers and you've got them on call. Be responsible for canceling entry authorization and termination when unacceptable conditions are present. Now, the attendant also can cancel the entry authorization. They can cancel the entry permit and require everybody to get out. And that could be for something as simple as lightning in the area. You better get out. There could be some other hazard, a fire that's going on outside of the permit, outside the space. But also, if they think there's something going wrong in the space, the slurred speech from the entrance is enough to make you decide you better cancel it and require them to get out and call the rescue team. So that's for the entrant. So the types of rescues, I've kind of alluded to it already. The non-entry rescue, that can be done by anyone, and that certainly is the only one that an attendant on the outside of the space can do, what we sometimes call a hole watch. The confined space attendant, that's the hole watch, basically. Whereas an entry rescue can only be done by specially trained rescue workers. They're the only ones allowed to enter the space during an emergency. The attendant never enters the confined spaces because, as you see down in the red spot at the bottom, 2 out of 3 people who die in confined spaces were attempting rescues, and that often is the entrant not following the rules and jumping in there to do a rescue, and they just pass out along with the rest of them. So here we're doing a non-entry rescue, maybe a training, the way it looks here, but you get the idea. They've got a hoist, like an engine picker. A lot of times they'll use a tripod. I think I've got a picture here of a tripod here also, and those are often used, put over. So the vertical, you can see how it works better in a vertical space, where you can. So that means that everybody that goes in the space has to be wearing a harness and be tied off to with a lanyard and a cable so that you can hoist them out. And so when you have more than one person in a space, this gets a little more complicated, huh? But it can be done. So he's just showing some of the rescues going on here. I found them in various places on the internet. Here's maybe something after the rescue, or it might be a training. It's hard to tell. Here's a rescue that's actually a real rescue I was taking a picture of. It's showing the real rescue going on. So rescue workers have a responsibility to do the following: know the hazards of the confined space, which they might be reviewing from the confined space permit, know the proper use of personal protective and rescue equipment, including respirators, practice rescue operations and know how to perform those rescues, and be trained in first aid and CPR, and maybe an AED training too. Know the company's confined space rescue program and rules and procedures. So here's practice going on here right now. Of course, you can see that guy hanging there is not real, right? But that's an important way to prepare and do your training. Here's another mannequin being rescued here. So yeah, you got a rescue practice going on. So that's done often. Annually at minimum, but it should be done more often than that, really. Here's just a picture showing, well, a mannequin on the right-hand side, but the other case is maybe a guy is demonstrating it. It seems a little bit too, pristine here. It's hard to say right now, but you see what they use to rescue. They've got cots, or I'm losing the proper term here out of my head here, but anyways, that's part of the training. You've got to have a way that you can pull them out safely. And so if you can't do it with the safety harness, a simple class 3 harness, then you have to go in. The rescue workers will go in and strap on a gurney. That's the word I was looking for. So the safeguards required when working in confined space: continuous monitoring and testing by a qualified person, continuous ventilation. The PPE is listed on the permit, the entry permit. There could be additional controls, including traffic management, barriers and barricades, lockout, tagout of all energy sources, effective communication between the entrance and the confined spaces. That might be done with something as simple as a horn, or it might be done with walkie-talkies of some sort. There could be specialized training for each member of the team involved with this confined space operation. Summary: a confined space has real or possible hazards, and it's called a permit-required confined space when it's got real or possible hazards. An entry permit must contain at least these basic minimum things: a list of the authorized entrants that are going into the space, the required protective equipment that you should use to go into the space, and it should have the initial test results for the air at the beginning. An entry permit must be posted near the entrance exit of the confined space. The type of hazard that can bury a worker alive is called engulfment. The first symptom, not the final symptom, but the first symptom of a slight lack of oxygen would be fast breathing and heartbeat. That can progress to worse things, but the very first symptom would be fast breathing and a fast heartbeat. I'm just going through these lists. Oxygen enriched in atmosphere can be just as hazardous as an oxygen-deprived atmosphere. This is giving you a hint to what kind of test questions you expect. That's what the summary does. The priority order for testing air in a confined space is oxygen first, then flammables, and then toxins. The air in a confined space is usually tested with meters, not canaries anymore. We don't use birds anymore in a cage, right? Okay, so you use meters. The type of rescue that is usually done by a confined space attendant is called a non-entry rescue. Rescue workers who are responsible for knowing first aid and CPR. You can have other people on the site, like you, as a construction manager or as a safety technician. It's not a bad idea to have that first aid and CPR training. Okay, so that's everything you need to know about confined spaces.